Now, what if your conditional and your converse were both true? What would that mean? Well, if they're both true, you can write what's called a biconditional. So they tell you to write the converse. If the converse is also true, combine them to write a true biconditional. So if two angles are supplementary, then the sum of their measures is 180. That's a true statement. Now, the converse would keep if and keep then exactly where they are, but you're switching the red and the blue. So it would say if the sum of 80, then two angles are supplementary. That's true also. Your conditional and your converse are true. When they mean the same thing, you can write what's called a biconditional. And the biconditional uses a really special phrase. If and only if. Remember that abbreviation. So when both of these are true, you can write this. Two angles are supplementary. I abbreviated. That's just the blue. If and only if the sum is 180. So that's just the blue words. That's just the red words. We didn't put if in the beginning. We didn't put then in the middle. We did blue, if and only if, red. And if you really wanted to, you could have switched these as well. When you can write a statement as a biconditional, that means it's a good definition. And when it's a good definition, it doesn't matter which way you write it, forwards or backwards. Good definitions are reversible. It's really important. So that's your section 2.2. Section 2.3 is on deductive reasoning, law of detachment, law of syllogism. So use the law of detachment to make a valid conclusion in this situation. If you get a hit, then your baseball team will win. We really don't know if that's true or false, but we're going to assume that it's true. If that's the case, let's see what happens with you. You hit a home run. Well, hitting a home run is getting a hit. That's about the blue. So if this statement is true and the blue is true, we now know that the red is true. So the law of detachment says, here's your answer, your baseball team will win. Now, you need to be careful because sometimes you can't use the law of detachment. Let's pretend for a second that this did not say that you hit a home run. I'm going to change the problem. This is still true. If you get a hit, your team will win. But let's say you strike out. You striking out is not getting a hit. So it's not saying that this is true. What can you conclude? You need to be very careful here. It does not mean that your team loses, and that's what a lot of people think. If you strike out, maybe there was only one out in the game. Maybe the next person up gets the hit that makes your team win. You can have a true conditional with a false hypothesis. Remember that. That's the difference here. Your answer here, if you strike out, if you cannot use the law of detachment, you cannot conclude anything. So that would be your answer to this one. And there's going to be one like that on the test, where you can't use the law of detachment. You can't conclude anything. Remember Dan and Jody go shopping, that whole thing. Well, if the mall's open, they go shopping. And if they go shopping, Dan is going to buy a pretzel. Okay, so you could use that law of detachment to conclude that he's going to buy a pretzel. Well, Dan bought a pizza. Can you conclude that? Be careful. Don't say no. If you say no, he can't buy pizza, you're wrong. He could buy a pizza. You just can't say for sure that he buys a pizza. You know that he buys a pretzel. You know that Jody buys a pizza. So be careful with what you're allowed to conclude. If the hypothesis is not proved to be true, you cannot conclude anything. As much as you want to say no, you would be wrong. Okay, let's go back to number 7 with Moose. If Moose is hungry when he goes to the pizza shop, then he'll finish a whole pizza. We don't know Moose. Let's assume that this is true. If Moose eats a whole pizza, then he goes through a pitcher of soda. Again, you're assuming that's true. If you have 2 true conditionals, and this is the important part, notice how eating the whole pizza was used in each one, and it was used as a conclusion and as a hypothesis. What you can do is eliminate that duplicated statement, and you can now say, if blue, then green. That's how law syllogism works. So you would say, if Moose is hungry when he goes to the pizza shop, then we know he'll go through a pitcher of soda. That's your law syllogism. That's deductive reasoning. It's different than inductive. There's no patterns here. You're using logic. Okay, last section on the test is section 2.4. There's 11 postulates that we already had a quiz on. You guys did really, really well on that yesterday. There's also the section on diagrams where they give you a diagram and they ask you, can you assume this from the diagram? So you have a list in your notes of things you're allowed to assume and things you aren't allowed to assume. And they're going to ask you a bunch of questions on the test about that. Points B, C, and D are collinear. Look at points B, C, and D. They sure look like they're collinear. Are you allowed to assume that? Can it be assumed? No. If they're not connected, do not assume that they're collinear. Number 17, if you don't know how to read this, you're probably going to have a hard time understanding what to pick. Line AC is perpendicular to line BE. That's what that means. Perpendicular means they cross at a right angle. Does that show that in the diagram? Are these perpendicular lines? Sure looks like it. Is the mark there? No. Can you assume that they're perpendicular? No. I'm going to draw another line on my diagram. And let's pretend that I'm asking you this question now. Are these 2 lines parallel? Can you assume that? No. They look parallel, but don't assume it. Are these 2 lines going to intersect? Can you assume that? No, you can't assume that either. So go over that list in your notes of things you're allowed to assume and things that you aren't allowed to assume.